Welcome back to the workshop. I'm Rich Jackson, and today we're going to take a look at DomainMCF and how we can prepare our data for modeling with machine learning in the cloud. We are going to prepare our data for modeling by using the Domain Manager to both look at some data statistics and to modify the intervals to ensure we get an accurate model that meets our needs. I'm going to make a copy of my domain table to store my modifications and take a look at the other videos in the series for guides on how to set up the Domain Manager. The first thing we want to check before modeling is that the domains we wish to model have sufficient data, and we can use the counts chart to display this. We will also load the thickness charts, which we'll use shortly. If some of your domains have very low interval counts, they will not model well, as there just won't be enough information to correlate between holes. We're looking for at least 1% of the population in each domain. If you have several similar waste domains that you want to model as one, you could just uncheck these. Undomained is the catch-all for everything not assigned to any other domain, so they will end up there. It is important to have these intervals as well as your main domains for modeling. If you want to keep your domain list tidy, you can also remove these unused domains. For similar domains that are poorly represented, you may wish to combine them into a new domain, like this F combined. Adding an asterisk will find all of these similar domains. And remove any of the individual uncombined domains. Alternatively, if you have multiple domain codes for the same domain type, just add this in manually. And remove any unneeded codes. The next important decision that we'll need to consider is what resolution do we need to model to? How thin a domain do we need to model accurately? If we look at our main unit here, while we do have some thin samples, the bulk of our thickness is above 1 meter. If we don't need this finest resolution, a helpful data prep tool is to combine by thickness. This will join these thin domains to the adjacent thicker domains. With this final data modification complete, we can decide on the resolution that we wish to model to, and for this data set, I'm going to look at my lower quartile thickness between 2.5 and 3 meters vertical resolution as a scale that I wish to make this model to. Do be aware that these stats are downhole lengths, so you may need to take into account the angle of your drilling as well. Machine learning loves data, and the rule of thumb here is to split the samples into equal distance points for an accurate model, and we want to split the domains into about 8 or 10 times the minimum thickness we wish to model to, in this case about 0.3 meters. And you'll see these intervals automatically display on your drill holes. Model resolution is also set by the block size, and we can auto-generate a model around our data, either rotated or axis aligned. And while it will auto-generate blocks of a defined size, for best results, we want to make sure that our sub-block spacing is about 1/4 our drill spacing in X and Y, and about half of the resolution that we want in the Z. So with a 1/4 sub-block ratio in this setup, we can set it up like this for our 3 meter vertical resolution model. Now for the easy part. Select our drill holes in our domain table and send them along with our block model definition to DomainMCF. We'll get a block count and time estimate before the data is uploaded to the cloud for processing. And when completed, you can just drop the domain legend on top of your block model to color it. If you are happy with the way things are modeled and want to generate a smoother looking model, one quick method is to decrease the subblock size with the sub-blocking ratio. Setting up DomainMCF to model grade trends uses a similar workflow, but if you'd like to model the grade trend independent of domain boundaries, a new domain group with just the undomain field will do just that. This time our splitting length will be a composite length for our samples, and we can check our grade charts to ensure that only clean data is going to get modelled, as we don't want any negative grades to skew our modelling. You can use the point extract tool that we saw before independent of the DomainMCF upload. And for grade trend models, you'll want to extract the grades from your assay table as well as the undomain table. These points do get saved to the samples container if you want to check them before sending them to DomainMCF. Only points of the complete set of data will be used in DomainMCF, and the warning being displayed shows just that. You don't need to filter out these points with missing grades, as this will be done automatically. If you do run an undomain grade trend model like this one, you'll want to adjust the block size to be a regular model at your previous sub-block resolution. And we can select the grade trends option and send the model for processing. Once you've loaded your new model, pick any grade trend field that you'd like to display, and as this is a trend and not absolute grade, you may wish to adjust the dynamic legends to highlight and understand the complexities of your deposit. Next week we're going to go back to Dan in Perth to take a look at some more implicit modelling options that we have available in Bulk and Geology Core, so join us then to continue our modelling journey.